Okay, welcome everybody to Pre-Calculus. We got a good one for you today. We are learning the law of sines. Oh, by the way, I did my video earlier this morning for the next class. And no, I don't. I'm not editing the video. It's not editing them. Okay, let's just talk about how to solve these triangles. We're actually not going to solve for them because I don't want to kill your time here. But how would you solve for x in this triangle right here to the left of top? You'd use the Pythagorean theorem. Why does it work in this triangle? Because what kind of triangle is it? The right triangle. Okay? Now this one, it only gives you 40 degrees. We don't know this or that. Okay? Can you use the Pythagorean theorem here? No. So this one is, I'll write this over here. So this is the Pythag method. Nice and easy. It's a right triangle. It's that guy right there. This one, there is a way to do it right now without learning law of sines, but it's a lot of work. So this one would be a law of sines method because it is not a right triangle. Okay?
You're welcome.
Moving on. So what is the law of sines? Well, first off, let's define this triangle real quick. So I'm just going to just pick random sides. Let's just say that's A, that's B, that's C. Okay? For angles, I'll use uppercase. For the sides across them, so A, across some big A is going to be lowercase a. Alright, across from B is going to be lowercase b. And across from C is going to be a lowercase c, which looks almost like the same exact thing. My son, when he writes his name, he uses uppercases and lowercases. His name is Landon. Big L, big A, little n, little d, O. I don't know if it's big or small. And little n. So he's like L-A and D-O-N. Maybe that's just how you should just write it that way every time. He can be French. That seems French to me, like a big L-A. I could be wrong. A little apostrophe afterwards. Alright, well, okay, let's do the formula real quick. Formula is just big proportions. See, when I did the video this morning, I had no side discussion. I got through the video like in 20-something minutes. I'm sure... I'm ignoring you people. Well, that only took 3 minutes and 11 seconds. Okay, I think of the notes that Ben Schneider does, I think he has these reversed. It doesn't matter. It's just taking one proportion. So a proportion of the angle on the opposite side is equal to the proportion of the angle on the opposite side. They're all just equal to each other. Okay, so since they're proportions, you can flip them if you want. Alright, we can flip one, you can flip them all. Okay, let's go over some basic vocabulary. Is oblique, and this is an acute or obtuse triangle. Pretty much, it's not a right triangle. Not a right triangle. So, this triangle up here to the right on the top is oblique, because it's not a right triangle. Well, we don't think it is. We don't know for sure, because not all the angles are here, but it looks oblique. So oblique just means that's when you use law of sines. The ambiguous case, I'm going to give you a very, very vague definition right now, and I'll come back to this when we get to it, because I don't want to get way too far ahead. So this is when we have either 1, 2, or no triangles using the law of sines. So you can have 1, you can have 2, or you can have none, and I'll get more into that when we get there. The ambiguous case, though, is when we're given certain sides and angles of a triangle. So, for example, for law of sines, we'll be given like angle, side. Nice and easy to find it. We'll be given angle, side, angle. No, actually that's more law of cosine. But anyway, there's one bad pattern that we're never supposed to use. Do you remember that from geometry? The bad pattern for... Yes! That's it! Angle, side, side. That right there is the bad one.
Oh my god,
Some teachers like to go, oh yeah, but we don't call it angle, side, side. We call it side, side, angle, because they like to be proper. I'm not proper whatsoever.
you can have side angle side.
No, so this is when the ambiguous case happens, and I will get into that when we cross that road, which is not right now. Okay, so let's just learn the law of sines. It's not too bad. You will need a calculator. Hopefully you know how to do multiplication. That's about it. No, hopefully you know how to do multiplication with a calculator. Oh, by the way, hey, don't be yelling out naughty words during the video. Please don't ever do that again. Terrible. Alright, so we have a triangle here. We have angle C, we have angle B, we have little b, and we need to find the measures of everything else. So, they give us a pre-drawn triangle. This is rare. They're really going to rarely give you that, but let's just use what we got here. So, angle C, that's obtuse, so I'm going to pick this as C. This is C. I'm going to call this 102.3 degrees. Angle B, does it really matter which one's angle B? Nah, let's just go over here and pick B over here. Which is going to be 28.7 degrees. And I have little b. I do know where little b is located. Where is it? Across from big B, which is going to be 27.4 feet. Okay? So what is the situation that we have? So just going, it doesn't matter where you start, but just start from one side and go around. I have side, angle, angle. So I'm good. Or angle, angle, side. Doesn't really matter. So no, we do not need to check the ambiguous case, which we'll get to that a little bit down the road here. So what we're going to do is use the proportion that we're given. What proportion am I given? So what letters do I have the uppercase and lowercase to?
B.
B. So let's use B. So sine of B, which is 28.7 degrees, all over the side length, which is 27.4, equals, well, let's go ahead and find little c right here, because that's the one I have the most information about. Okay? So we're going to do sine of 102.3 degrees all over little c. Do I need to show you how to solve for c in the calculator, or are you all good? Okay, make sure that you are in degree mode. Sorry, I'm going to kind of cover up the... try to make the glare not too bad. So, all you're going to do is cross multiply. So you're going to get c times sine of 28.7 degrees equals 27.4 sine of 102.3 degrees. Okay, so let's go ahead and do that. So we're going to get the... Let's work on this side first, and then we'll just divide that over. So 27.4 times sine of 102.3. Okay, gotta make sure it's in degree mode. You can always just check right up degree. If you need to change it, you go into mode and change it. Alright, so I have this. Kablamo! That's not my final answer though. What do I need to do to get C by itself? That gives me an answer of okay. So it's going to be 55.747. Alright, we cool? Do I need to show you how to use the calculator ever again for that? Maybe. Okay. Daniel says so. Alright, okay, cool. So again, this wants me to solve the triangle, which just means find all sides, all angles. So I have one of the sides. Great. I was given 3. Any ideas how to find the other ones?
908.
Thank you. I know exactly what you're talking about. How can we find angle A super easy without really using any pre-calculus? Yeah, so this whole triangle is 180, so 180 minus that gives us angle A. What is angle A? 49 degrees. So all I have left to find is little a. How do I find little a? Yeah, so we have this still. We're going to still use this first proportion. But now we're going to change this second one into sine 49 over a. Always use your givens, because it's a more precise answer. Okay, again, I'm always going to use this, the b, because it was given to me. And then solve for a. What did we get? 0.61. Okay. And I believe that we have to label everything because it gave us units. What's my units? Feet. So just put feet on all these guys. And that is your law of sines. It doesn't get harder unless it gets harder. It doesn't get harder unless there's an ambiguous case. Alright, that's about it. Alright, let's move on. Let's start talking about some angle measurements. Oh, it's disappointing. I hope there be bearings here. No bearings yet.
I have a question.
Yes?
Is this an easy unit, like the test portion that you think? Or is this like one of those, like, it's going to get really hard right before?
Just today, though. It's hard
Today's
today.
easy?
No, opposite.
Oh, today's a hard one?
Yeah, so easy. Easy. I don't want to say hard, but
Like, more challenging.
more work.
Not straight to
More work. More steps. More steps.
More chances.
More opportunities for failure.
Oh, I like calm down. I like Daniel's version of it. More chances for failure.
Well, I'm real.
Okay.
Daniel's nice. I'm not.
I know.
At least we can agree on something. Okay, because of prevailing winds, a tree grew so that it was leaning 6 degrees to the west of the vertical. Wow. Okay. At a point 30 meters east of the base of the tree, the angle of elevation to the top is 22.5 degrees. Find the height of the tree. So here we go. So we got some tree that's leaning west. Is west left or right? So he got some tree. All right. So here is some tree. This is my tree. Deal with it. That's my tree. Okay. All right. And then at a point 30 meters away, which is right here, so this is 30 meters, it says the angle of elevation, which is always going to be this angle right down here, is 22.5. We need to find the height of the tree. So, well, there's actually one more angle we can find. You said it. What is it? Why is this 96? Yeah, it's 90 degrees because it stands up straight, and then because of prevailing winds, it's tipped over an extra 6 degrees. Okay? So that's my picture. So in this picture, what's my angle side combination I have here? Angle side angle. So is this ambiguous? No. Okay. So this one's not that hard. Let's just label this as H for the height of the tree. I don't need to solve the whole triangle. I just need to solve just this one side. How would I set this up to solve it? So I have this side, so I need this angle, don't I? Can't I find that angle?
Yeah.
What is it? Yeah, it's 180 minus that, which is 61.5. Oh, okay. Now is it easy to find my ratio?
Yeah.
You're not trusting the 61.5, or we're good? So sine 61.5 degrees over 30, because that's what I'm given, I know that's true, is equal to my, what angle am I using? The 22.5. So sine 22.5 degrees all over the height. Just cross multiply, so 30 times sine 22.5. Divide that by sine of 61.5, and we're going to get a lovely answer. 13.063. Let's use 3 decimal places, please. Round it to a 4? Alright. Or you can truncate it, I don't care. We want me to write 4, or scribble this out, write 4, or just leave it 3? Whatever you want, okay? I don't care. I'm leaving it. I usually truncate, because when you truncate, you don't have to think. Alright, any questions so far? Okay, number 3. We have, so this one they don't draw a triangle for us, so I usually just draw the same triangle all the time. Like, this is it. It's not always to scale. We'll just deal with it. So, this is usually my angle A. This is usually my angle B. This is usually my angle C. This is the same triangle I always draw, no matter what. I understand it will not be to scale. We just deal with it. Okay, so what do I know? What's 85 degrees? What else do I know? Okay, so this little a side right across is 15. And what else do I know? Here's little b. Alright, and what situation does this represent? Angle, side, side. Uh-oh, am I going to get fired if I write this down? I'll put little dashes in between so it doesn't look as bad. Angle, side, 5. That's what it looks like. This angle, side, side. So, hey, let's go back to the front. Let's talk about the ambiguous case more. Okay, so I want to talk about everything right here. Okay, so again, this has to do with angle, side, side. So, I'm going to actually, you keep the side up. I'm going to do a little bit of a demo for you. A little magic trick. Alright. So, here is, I forgot how I did this. It's a pencil. Got a problem with it? Someone stole it. Whatever. It was on this desk. Okay, so here's the things that we know. This angle will always be the same. This pink pencil will always be the same, and so will this yellow pen. This is our situation we have. You agree? This angle, so this angle is the same. This length can change, right? I can just make it a little shorter if I want, moving it down or whatever. Okay, but the constants are this angle, this pink pencil, and this yellow marker. I'm going to argue with you. It's totally possible that I can make 2 triangles. Okay? The obvious one is right here. You agree that I just made a triangle, keeping consistent with this angle, that side, and this side. Pink, yellow, and then this angle with the little green thing on there. Daniel, do you know what the other triangle you can do is?
Yeah, you just change the angle of the yellow pencil.
Like this. So again, ignore this length right here. Alright, that length's gone. So now we have the same angle, the same side there, but what changed? this side, and obviously this angle is going to change and that angle is going to change. So this is where that we can have a situation where we have two triangles. Okay. Now I'm going to change this up to okay. Do not do this at home. We have the no, this is sharpened. All right, that one wasn't sharpened. What do I care? So we have the same angle, length, and I just changed this length a little bit right here. Okay. So do we agree that this is angle, side, side? But now what happens? Can I make a triangle? No, poor little guy. Can't make a triangle. Right. So then you're kind of stuck. Okay. So this is totally possible to have no triangles and to do one triangle. The reason I know this is going to work because these are the same lengths. The only way to do one triangle from here is right here. Okay, actually no, I'm doing it the wrong way. Let's use the KD pencil as the base. Okay, so for this one, the only option is this, because these two pens are the same length. Okay, so those are your options. It's not always have to be the same length. There's certain situations where it has to do with this angle that's being formed over here. Like if this is an obtuse, then you can only do one triangle. So there's a couple different situations that change there. But that's how we get to the either the 1, the 2, or the none. So let's go ahead and I'm going to draw a lovely picture for you right here so you can kind of see. So let's say that in this situation we have this. So we have this angle A. We have little b, we have little c. And we also have this right here. So this is an option right here for angle C and angle B. Because again, we're given these right here, and this is A. We're given those. Or we can open this thing up a little bit and have this triangle where it's the entire thing, alright? So, or this could be A. Alright, so these are options. There's the triangle I just drew, and then if you open it up more, you can get that one. Okay? Or you can have the old little short guy like that. Alright, so this is angle A, this was B, this was A, and this one you're going to have none. So this one you can have 2, this one you're going to have none. And I kind of just showed you the other situations where you can have 1. But I'm not going to draw that one because most of these answers we have for law of sines just have 1. But if it's ambiguous, you can have 2 or you can have none. Here's the good part. Like, if you just have no triangles, it's very easy to do. You just do one thing and like, oh, it doesn't work. Okay? If you have 2 triangles, you just need to do the problem a second time. That's what makes it harder because there's more opportunities for failure. Alright, so that's the ambiguous case. So now let's go ahead and talk about our good old angle side side guy right here. So, do we need to check the ambiguous case? Of course we do, yes. So, let's go ahead and do the first proportion that we do know. So for these, you only just have one proportion you can do. What's the only proportion I do know? What letters match up? A's. So here we go. So we're going to do sine of 85 over 15 equals, and what's the other angle I have to use? I have to use B. Okay, so this one I'll do with you. So all I do for this one is I don't cross multiply everything over, just the 25 over. Okay, so I'm going to get 25 times sine of 85 over 15. Okay? And that's going to equal sine of B. So you're going to find this out, and then you're going to hit second sine on here and go from there. So here we go. So we're going to do 25 sine of 85. Divide that by 15. And now to find B, I hit second sine, pull this up right there, hit enter, and hit enter again, and I must have just did it wrong, right? What is it?
You don't have a triangle. I just had deja vu. I remember her saying, you being like, it's an error, and then Avery was like, it's not a triangle, and you were like...
Okay, alright. So this one is no solution.
All that for no solution?
It's pretty nice, it's less work than the other ones. So if you notice, this length right here at 25 is much larger than this one right here, which means that it might not work out. Okay? So just kind of be aware of that. Might not work out. This is one of those situations where you got that little short guy right here, a little short pencil. Alright, move on. Next one. Okay, we have ABC, we have little a, little b, big A. So let's go ahead and draw the same triangle that I always draw. Okay, so what situation is this? I know. You know. Alright. Angle dash S dash S. Okay, so I'm looking at this and I'm like, alright, that guy's way too small to work. Are you thinking that too? So let's do the same situation that we did before. Oh, nope, the KD pencil was here. But this one is going to work. Okay, so, hey look, dangly's not going to work right here, right? You can't even see it, so of course it's not going to work. So dangles is not going to work right here, right? What if I shorten up this angle a little bit? Now will the dangly thing work? Yeah, it will work. Okay? So if this angle is smaller, it might work. So it's not always a, oh, that side's bigger, it's not going to work. So just kind of be aware of that. So let's go ahead and set this thing up. So what's the only setup we can do? I've got the right yes up there. So I heard you, sine of 20.5 degrees all over 12 is equal to sine B over 31. Alright, did we get a B value?
Yeah,
64.783. Okay, so let's finish it up. So we got angle B right here, which is our 64.783. Let's just finish this one up. Oh, you can do that last one pretty easily, can't you? You don't need to do law of sines to figure out that last one. What's angle C? You just do 180 minus the two values we have. And you're going to get 94.717. Okay? And you can find little c by doing the law of sine. So again, we're going to use I'm going to do the side work right over here. We have this sine of 20.5 degrees over 12 equals sine of c, which we have that c value, all over little c. So make sure you use the whole value. Don't just put in 94.717. Your answer is going to be off by a little bit. You need to use the whole thing. Okay? So make sure you do sine of, and then come back up and pull this up. All right, what do we get for c? Okay. In your calculator, do not use the rounded version. It will not be a precise answer. You need to use all the numbers the calculator gives you.
When I subtracted though, that was the exact answer.
So you probably should have used the whole version of B then. Yeah, use the whole version of B to find C, because there's more numbers to B. Find the whole version for C, and then go ahead and do this. You just gotta go up. Want me to show you how to do this? My bad, I thought you could do it. So 31. Okay, so you have this, and to find C, you just do 180 minus the 20.5 minus, you can go up and pull it up, right there. Okay, so we got to use that whole number to find this, otherwise you're going to be off by a little bit. So now we're going to do this sine of this times 12 divided by sine of 20.5. And you're going to get don't need to put a unit. If there's no unit in the problem, don't put it. So this is half of our answer. Yeah. So now we got to see the second triangle. So this is how you do it. You're going to take your angle right here, angle B. So this is triangle 1, by the way. Okay? You're going to try out angle B in triangle 2. What if this was, I'll just box it because this will be our second answer when we get to it. What if this opened up? You can figure that out by doing 180 minus my angle B. So you can go back up, pull whatever your angle B is. Okay? And that's going to be your other angle B.
Wait, what?
You only do this for the ambiguous case. Because, again, in my two situations, you have that little swinging pendulum, pretty much. Right? So here's my KD pencil and my whatever base right here. Okay, we just found this guy right here. Okay, in order to swing this in, we're gonna find to see if this is gonna give me an obtuse angle. Sometimes obtuse, sometimes it's not. Just it's easiest for me to demonstrate this using obtuse because it looks more obvious than anything else. So we need, in order to swing this in, we're just gonna subtract it by 180 to see what that value is for B. Okay, because again, when I'm finding angle B, it's this guy right here. I have this value. Well, what happens if I swing it like that? That value is right here. That right here is our, what was it, 64.783 is right here. So what's on the other side of it? 180 minus that, which you just said is going to be that 115 number. Okay? Does that make sense at all why we subtract 180? You okay? Was it the funny bone?
No.
Oh.
I'm not laughing.
Yeah, always the bottom right. Okay, I want to say always bottom right, but how I drew it, yeah, it's that one. Yeah, so it's always the first one you find. Okay, so 115. It's totally possible for this triangle not to exist. That's going to come down to, is there an angle C that exists? So how would I find angle C? So it would be 180 minus the 20.5 minus this 115. And there clearly is an angle C. Okay, which is, I'll put little degrees on those. Okay. If this propped up a negative number, would there be an angle C? No. No. Okay.
And the triangle wouldn't exist.
And then, so we would only have one triangle in that case. So angle C, or sorry, side C, we're just going to do our sine of 20.5 degrees over 12 equals sine of our new C here over our little C value. So again, this is going to be this C value right here. Do I need to do this for you, or can you just tell me what it is? 984? 24. 24. Okay. That's as hard as it gets. Alright, we have the same thing. It's going to end up being one triangle. Do you want to do it together or just move on? Okay. What's that? So you can do the first triangle, no problem. You'll get this first box. It's not a problem. But then you do the second box, you'll get a number that's too big. So then when you do 180 minus that number, you're going to get a negative value. Okay, I'm going to just leave it on the notes, available for the notes. If you want to see it, it's on your own time. I don't want these video notes to be like an hour long. Okay, so this is why I was trying to say, like, last class was nice to start thinking about it. If you didn't, that's okay. No big deal. Just because I don't want to be sitting up here teaching, because I'm sure you're all checked out right now as it is. So, let's move on since you're all checked out. So we got the course for a boat race starts at point A, proceeds in the direction of south 52 degrees west to point B, then the direction south 40 degrees east to point C, and then finally back to point A. Point C lies 8 kilometers directly south of point A, and that's approximately the total distance. Oh, by the way, Daniel, your question that you had last time, what's the difference between a heading and a bearing? I said there is a difference, but I guess there wasn't a difference because the notes were typos. The notes last time had a bunch of typos. Heading is when we start from the top, and that's just the degree value up to 360. Bearing is short for compass bearing, which is compass values. Okay, so I didn't really realize that until the next class, that those were just all typos, because again, the words aren't so important, but if we ask you for a bearing, then I want compass bearing. Because in my old school, I would always say compass bearing. I'd always add that in, but I guess here we're not adding the word compass. So, all right. So let's go ahead and draw this. So where should I start to draw this? If I'm going to start to go south, I could probably start up. All right. Let's go ahead and start up. So Ray starts at point A. Call this A. It's going to go southwest 52 degrees. So what quadrant is that in? It's point B. Does it say how long I'm going? That's a shame. And then southeast to point C, 40 degrees. So it's going to be this. I don't really know how far I'm going, so whatever. I'll just. Oh, I think it says it's directly south, right? No. It says point C lies directly south, so I will just want to draw it long enough. Great word problem here, right? So our resultant here is directly south 8. So I really should probably figure some of these angle values out, because it's going to approximate the total distance of the race. So it's going to want this value, which I'll just call, well, this is A, this is C, and this is B, correct? So we got little c and little a. So I probably need these angle values, and we can find them. So what's this angle right here? We're lucky that this is directly south, so we can find this one. What's this angle measure right here? It's 52. What else can I find? Okay, so if this was right here was 40, we're going to split it in a second. Actually, I'm not actually going to find this one right here. If this right here is 40, we agree that this one would be 40 degrees right there. Alternate interior angle makes that this one, which is great because I want that, which is 40 degrees, which makes this big guy something. 180 minus those two numbers, which would give us 88 degrees. Okay, so I need to find A, I need to find C. I'll find C first. So what's proportion, what letters am I going to use here? B, because we know everything about B. So we got sine of 88 over 8 equals, we'll find C first, sine of 40 over C. Can I just tell you what it is for speed, or do you want to do it? Just you just use the calculator. So this is going to give me 5.142. I'll do labels at the end. And what's the setup for the other one, for A? Yeah, sine 88 over 8 equals sine 52 over A. And this is going to give me 6.307. Did I answer my question? What's the total distance of the racetrack? So they started here, went there, there, and back. So I need to add all those up. So I need to do 5.142 plus 6.307 plus 8. Gives me 19.45. 452? 449? 449. Kilometers. Okay. We're starting to get a little repetitive here. Do I need to do this next word problem? I'm looking at it. It's like the same idea. It's the same exact idea. So it's just a matter of, can you draw it with the bearings? Do you want to practice that or just move on to the last thing? Move on. You can practice one of this on your own. Look at the notes for the answers. Here we go. Okay, finding area of these triangles. So there is an easy way to do it. Of course, this hole punches right through here. That should be a 7. Silly hole punch. How do you find the area of this triangle? 1/2 base times height. Okay. Same thing. What did you say? Yeah, right, it's the same thing. Okay. I usually don't use length and width unless it's volume for 3D. Base and height is 2D. So this is going to give me a good old 35 there. Yeah, because I got a right angle. This is also going to work, even though it's obtuse. Same idea here. So this is going to give me an area of, you do it in your head real quick. 12. Come on, people. And this one does not have a right angle, so I don't know. Don't you wish there was a formula? Let's just go ahead and label this triangle so we know what we're talking about. Here it is. It's 1/2 base times height, like it usually is, right? So I'm just going to do AB because there were the sides, AB, and then times sine of whatever the middle angle is. In this case, it's going to be C. So you're going to take the two sides that you know, the sine of whatever that middle angle is. So this is always going to be a side angle side. Side angle side. Okay. It's got sass.
Random question. Is our skills check over this stuff going to be like the paperwork from last time?
Yeah, I'm going to do it on paper.
Okay.
I'm moving away from that stupid quizzes thing.
You do you.
I always do me. Find the area of a triangular lot containing side lengths 24, 18, and they form an angle of 80. So this is just a really convenient problem here. Not much you need to do. So 24, that's fine. That's 18. It says that it forms an angle of 80. So it gives me absolutely everything that we need. So how do you set this up to find the area? 1/2, 24, 18, sine of, and you just type that in the calculator. I'll wait for somebody to shout it out loud. No, it's not 127.
212.718.
Yeah, 212.718. What's my units here? Yards what? It's area. Woo! We're done with that marathon.